One of the special cases we're going to look at is a situation like this. So it's an OR, so I'm thinking that my graph should look like this when I get done. So let's go ahead and do that. So if we divide this, we have x ends up being greater than -4, or, now notice I'm dividing by a negative, so I have to switch the sign. So the sign gets turned around, so I have x, because I'm dividing by -6, x is greater than now or equal to -8. And now I want you to notice something, that in this case the greater than or equal sign are both pointing in the same direction. So actually there's going to be some overlap here. So if I graph this each one separately, x greater than -4, so that here's my -4, x greater than is going to be going this way. And then if I graph this one, x greater than or equal to -8, greater than or equal to, you'll notice that there's an overlap here. And actually this solution overlaps this solution. So actually this solution here of x greater than -4 is actually included in this solution here of x greater than or equal to -8. So actually I could represent this solution as just using -8 greater than or equal to, and then because it's going the same direction, it ends up picking up this greater than -4. So notice this graph doesn't look exactly like I would have expected it to because it's an OR. So usually this is going to happen again when you end up having to reverse the inequality sign and they both end up pointing the same direction, meaning they're both greater than or they're both less than. There's going to be that overlap. So your answer is going to look like that. So watch for some cases like that. Now there is one other special case I want you to look at. Here's another special case I want to look at, and this goes to understanding the and what it means and how that I need to interpret that. It's not just a mindless just and it always looks the same thing. And what I mean is look at this. This is an and inequality. So right away I need to think and, remember one of the conditions of that is it satisfies both at the same time. Okay, so the answer that I get has to satisfy both at the same time. So I'm going to go ahead and solve this inequality. Go ahead and adding 3 to each section here. So I've got -15 greater than 4x greater than -12. Then I'm going to go ahead and divide by 4. So I've got -15 over 4 greater than or equal to x greater than or equal to -3. Alright, now just let's convert this very quickly as -3. Let's see, 12, 3 3/4. Okay. Now remember, and I'm looking for a number that is both greater than. Whoops, sorry, I made a mistake there. Let me erase it real quick. -3 and 3/4. I'm looking for a number that where x is greater than -3, and at the same time it's less than -3 and 3/4. So let's look at that graphically really quickly. Here's 0. -3 here, so here x is greater than -3, so that would be these up here. And at the same time x is less than -3 and 3/4, so that would be those down here. So what number is greater than up here and down here at the same time? Well, there's no such number. All of the numbers that are greater than -3 and less than -3 would be this is a negative, sorry. All the numbers that would fit this would be in here, but you'll notice that's not the solution. There's no answer here. So this is a case where there's no solution. So be careful when you're doing these problems that just because you get an algebraic answer and you just graph it like this, remember, an and has to satisfy both equations. An and most times, remember, is going to look like this. Well, this graph doesn't look like this. There is no number that's satisfying this thing, so there is no solution to this. So be careful with those. And again, it goes down to understanding what the word and means. One final special case I want to look at, again, is something that might come up, and here's an example. So again, I see it's an OR, so I would expect my graph to look like this and like this. Okay, so let's keep that in mind, but let's see what happens. So we're going to go ahead and solve this inequality. So I'm going to add that to each side. So a is greater than 4, or we put 3a here is less than 15, a is less than 5. So it has to satisfy this one or this one. So if I graph that solution very quickly to get a picture, all right, a is greater than 4, so that's going to be these up here, and less than 5, whoops, got a little ahead of myself here, 5, less than 5. Well, you'll notice that by the time I put these together, all of the numbers up here, every number is covered. The numbers greater than 4 go up this way and includes 5, so even though 5 is not included here, when I go down this way, it picks up the 4 that's not included. So actually, every answer or every number becomes a solution. So here, I could say that all real numbers are the actual solution to this, because any number will work. So again, it doesn't, just because it does look like this, there's some overlap, I need to interpret what it looks like. Okay, so we don't want to just get mechanical about just doing things and not thinking about what they actually mean. So, and sometimes a graphical picture can help us see that even better. Okay, there's one more video. There's one more video you want to look at, and that's an application of the AND inequality